of x, g of x, h of x. Function notation is just a fancy way of writing your y and labeling your y. Does that make sense? Yeah. Okay. Because you can now say F, G, H, J, K. You can call it whatever you want to call it instead of just saying Y. Or have to use Y1, Y2, Y3. Okay. Function notation also represents that you have a clear input, right? X is your input. All right. So keeping that in mind. Now, way back in elementary school, you guys learned the 4 basic math operations: addition, subtraction, multiplication, and division. Correct? Yes. Okay. This week we learned composition. Composition is where we are inputting one function into another function, or we're evaluating one function and then using it to evaluate the second function. Correct? That's what we've been doing. All right. We're now going to put this all together. Okay. So now we're putting it all together. So we're going to start with our first tab. Okay. It doesn't matter if your paper is this way or this way. I really don't care, but whichever one is, that's going to be your first tab. So we're starting with our first tab and we're going to title it. Okay. On the first tab title, you are writing this: addition/subtraction. On the tab, Nayla. On the tab. Hey. What are y'all? Wait, what? You can write it horizontally, you can write it vertically, you can write it diagonally. I don't care how you write it on this tab. Just write it. You're writing, let me highlight it. You're writing this. Are you being for real? You're writing the whole
you literally skipped the middle part, right? I'm just saying, like, right.
Is you. When I started, the generations were totally different. I didn't say it was different. That's the most PC way I could describe the situation here. I've never had this complication making this foldable, and it's like my 5th year making this foldable.
What are the side cartoons?
No comment. All right, are we done? Yes. What is confusing? Oh, this is confusing. I'm like, what? Okay. Yes. Are we good? All right. So now we're going to open that tab. We're opening the tab that we just wrote on. The one. It doesn't matter. Whichever way you want to write it, I don't care. Okay, we're opening it. Yes? All right. We're going to do 2 examples. One on one behind it, and one on the other side. How many examples are we going to do? 2. One behind and one on the other side. Yes? That's what behind means. Yes.
So one says, I think she just said that like 1,000 times.
Okay. I want this recording to represent that it's not me, it's my students. And I'm trying real hard. Okay. All right. So we're going to be using the same function the entire time. Okay. The same 2 functions will be used the entire time. All right. So we're going to write down f of x equals g of x equal. It is highlighted for you to write down.
Yes, we will. Yes.
Oh, God.
It is. What is highlighted, you're writing on the back side of the tab.
Can I go to Brown's class? I forgot my car keys in there.
How's that life or death?
Because I lost my car keys.
Not life or death. You could have just called and said, sir, can you hold my keys for me? All right, here we go. Anyways, did we write it down?
Yes.
All right. What are y'all doing? I said you are writing what is highlighted. If you wrote anything else at this moment behind this tab, again, different. I hope so. All right. This slide said we're going to do what with these two functions? Addition. We're going to add them together. Okay. Hence why it's behind the addition and subtraction tab. Crazy. I know. I know. Okay. Mind blowing, right? That behind that tab is what we're going to do. Okay. All right. So here we go. So we're going to do f of x plus g of x. So what is f of x? 2x plus 1 plus g of x. What is g of x? X squared plus 1. Yes. Is it me?
No, it's not.
Okay. All right. So at this point, now when you are adding with variables, all you're doing is one, you're going to write it in order of decreasing power for the variable, and you're going to combine like terms, right? So we're writing in order of decreasing power and combining like terms. So what is our largest power? X squared. So we're going to start off with x squared. X squared has no friend to combine with, correct? Okay. Next is 2x. Does it have a friend to combine with? No. And then lastly, we have 1 and 1, and that makes 2. The mathematical order matters, but logically you can add in any order. But when you write it out as a polynomial, you write from decreasing power. Okay? Okay. Are we good?
Yeah.
So this was our addition example.
Yeah.
On the right side of that same tab, we're going to do subtraction. Yes, subtraction is just a tad bit different. No, this is what that means. When you see f plus g of x, it means you're adding the two functions together. Okay? All right, here we go. This time we're on subtraction and we're doing on the right side of the same tab. Okay? It has f of x minus g of x. So you either will see it as f of x minus g of x, but the function notation is f minus g of x. Does that make sense? It does not mean we're multiplying. It means we are subtracting the two functions. Okay? With subtraction, you have to put the second one in parentheses. Okay? So when we're subtracting, we have to protect the second one. So we're going to end up with f of x, which is 2x plus 1 minus g of x. And g of x is x squared plus 1. Okay, the reason why we use parentheses is because that minus has to be applied to every term of that expression. Okay, it has to go to every term. So we have to distribute the minus. So now we're left with 2x plus 1 minus x squared minus 1. Are you with me? Okay. And then now it comes down to writing in decreasing power and combining like terms. Okay. All right. Does negative x squared have a friend? No. So it's just negative x squared. Does 2x have a friend? No. And what happens to a positive 1 and a negative 1? They cancel out. They equal 0. So that means my final answer is negative x squared plus 2x. Okay? How do we feel about addition and subtraction of two functions? Woo-hoo. Okay? So we're going to close the first tab. Okay? And we're going to open the second tab after we write on it. Okay? We're going to title it and then open it. Got it? We're going to title and open. I'm about to flip the. So the next tab is multiplication. And these are the 3 function notations for multiplication. Okay? So now we're on multiplication. So we're going to write down multiplication.
Oh yeah. Those multiplication, right?
Yes.
Okay.
Do I need to highlight again?
Yeah. Do a better job this time.
No. You guys use more common sense this time.
Where does those come from?
What do you mean?
Or NF?
Or?
Yeah.
Or? The word or.
No, or NF.
In is a number. In stands for number.
Oh, I see it.
In stands for number.
We lack that a lot.
In stands for a number. In can be any number. I used to write the number sent. I normally do, and someone's like, "Why'd you write hashtag?" It's a pound number. But when I stopped that with this generation because I kept getting at it. Why are you writing hashtag?
That's sad.
Exactly. And I don't have time for that. So I put an N for number. And then you still ask me what the N was. So, All right. Do we have our second tab finished? Because mine is.
Yeah.
Now I'm going to open the second tab. Really? The second tab. Okay. Okay. All right. Look at your little trolls. I don't have time for you. Okay. So we're on the second tab. We're going to do 2 examples. Okay. Now, this is the tricky part. One example is really small. So you don't really need the whole left side to the whole right side. So if your left side kind of feeds over, it is A-okay. Got it? Does that make sense? Okay. All right. Here we go. We are using the same functions as before. Did I not tell you we're going to be doing that? Yes. Our f of x and our g of x, for the sake of sanity, are the same. Okay. So we have f of x equals 2x plus 1, and we have g of x equals x squared plus 1, and we are multiplying them together. Okay. So we're multiplying these 2 together. So we have 2x plus 1 times x squared plus 1. All right. So in Algebra 1, you learn a few things. Depending on your teacher, they may have called this multiple distribution, double distribution. They may have said FOIL. They may have said box method. If any of those ring a bell, then that's what we're doing. One of those things that ring a bell for you, okay? So I'm going to model just to see which one you want, okay? So multiple distribution or double distribution or FOIL just means that you're taking the first term and you're multiplying it times every number in the other one. Then you're taking the second term and you're multiplying it times every number and the other polynomial, binomial. Okay, and then you're combining the like terms. So I'm going to go. Are you ready? All right, so we have 2x times x squared, which gives us 2x cubed. Then we have 2x times 1, which gives us 2x. Okay, I've now multiplied this term times every term in the other expression. Now I'm going to do the next term. 1 times x squared is 1x squared. And then 1 times 1 is 1. Okay, does this look familiar doing? Some teachers would have called it, back in my day, FOIL. They said to stop calling it FOIL and just called it multiple distribution because it doesn't, huh? Because you multiply first term times first term, outside term times outside term, inside term times inside term, last term times last term. Okay? However, FOIL only applies if it's a binomial times a binomial, which means two terms. Whereas multiple distribution occurs because it can have more than two terms, right? All right, but anyways, your other option, if your teacher did a box, if you want, 2x plus 1, x squared plus 1. And then you multiply it using the box. X squared times 2x is 2x cubed. X squared times 1 is x squared. 1 times 2x is, and 1 times 1 is 1. Are the results the same? The results are the same. So whatever you were taught or whatever, I'm not changing it. I'm not saying forget it. Choose it and keep going. Okay? All right. So anyway, after we done this, what is our final answer? Well, our final answer, huh? Makes you think of a Punnett square? Yes. All right. What is our largest exponent? 2x cubed. Then what's our next one? X squared. Then our next. And then finally, 1. Okay. There was no like terms to combine, correct? How do we feel about it? All right. Remember I said that you just need a little bit of room on your right side. I know you heard me say that. Okay. On the right side, you just need a little bit of room. I'm going to just draw a line to model this being my right side. Okay. So for our n, I'm going to let n equal 3. Okay. All that means is that if there's a value outside of your function, it's distribution. That just means you're going to distribute. So when this happens, that means you're going to distribute. Okay. So we have 3, and what is f of x? What's f of x? 2x plus 1. And all I'm doing is doing what? Distributing. So that leaves us with 6x plus 3. Okay? These are your 2 examples of multiplication. A function times a function, or a number times a function. Yes, because it only says 3 f of x. Then you would multiply those 2 and then multiply by 3, then distribute to 3. I don't know. Good. All
Let's watch video on your channel.
right. Yes. Okay. We're now on to our third tab. Okay. Third tab. Ready? Your third tab is division. No, leave it open. Go for it. If that makes you happy, leave it open. Okay, so our third tab is our division tab. So we have f of x divided by g of x, or it would be seen as f over g of x. Are you being dramatic?
No.
Oh. Okay. I have mine written. What are you doing? So we're going to open the division tab. Step 1, open the division tab. For division, you only need one side. I don't care which side you use. You choose your side. Logically, I would use the right side, but you know, you do you, boo. Okay? You do you. Whatever makes your heart happy. Okay? All right. So now we're going to be dividing f of x divided by g of x, okay? And we're still using that f of x equals 2x plus 1 and g of x equals x squared plus 1. Okay? So it says f of x divided by g of x, which turns out to be 2x plus 1 divided by x squared plus 1. When you are dividing expressions, you actually do not want to write them in a division sentence. You want to write it as a fraction. Okay? Huh? Yes. So write this as a fraction. So the first expression is your numerator. The second expression is your denominator. So it becomes 2x plus 1 over x squared plus 1. Okay? Normally, you would simplify, but there's nothing to simplify, right? They have no common factors, so there's nothing I can factor out. So then this is where you would stop. That's it. Okay? Unless you can simplify, then you stop. That's not a factor. A factor is something that they both are being multiplied by. One is being added on. Cannot eliminate the one because it's addition. Like, I'll show you. This thing is in my way. So for example, Jalen asked, what about when could you eliminate? If this had been 2x plus 2 over 4x squared plus 2, that means that I can factor out a 2 from each one of these. Does that make sense?
Yeah.
So I can factor out 2 in the numerator, and that leaves me with x plus 1. I can factor out 2 in the denominator, and that would leave me with 2x squared plus 1. So now the 2's would cancel out. A factor you only can eliminate factors. Yes. So then the simplify would be x plus 1 over 2x squared plus 1. Factor means, divide out a factor, like something that multiplied to make that happen. Like the factors of 6 are 2 and 3, because 2 times 3 equals 6. The factors of 2 are 2 and 1, so I can divide out a 2. Okay. All right. But this is irrelevant for this problem. I just wanted to show you when you would have to simplify, which is a good example on your classwork yesterday. So remember on your classwork yesterday, you had the -2 over 4x to the third, and you could factor out a 2, right? Which reduced it down to -1 over 2x to the third. Okay. All right. Last one is our most recently learned operation, which is composition. So our last tab is going to be composition. We have composition, which is F composed of G of X fog, or F composed of G of X. They mean the same thing. Okay, our last tab. So we're going to open the fourth and final tab. And again, you only need one side. Correction, you're going to use both sides. I'm sorry. All right. So on one side, we're going to do F composed of G of X. And then on the other side, we're going to do G composed of F of X. This is representing my left and my right of my fold, in case you're wondering. I'm not telling you to draw a line. Huh? Yeah, I just wanted to clear the air and make sure that we didn't draw additional lines. I'm done. All right, so F composed of G means that I'm taking G of X and I'm plugging it into F. Does that make sense? So f, and what is g of x? X squared plus 1. That means everywhere in f, wherever there's an x, is going to become x squared plus 1. So we now have 2. Instead of x, we're writing x squared plus 1. Plus 1. We're going to simplify this. In order to simplify, we're going to distribute and combine like terms. So what do we get? 2x squared plus 2 plus 1. So what is our final equation? 2x squared plus 3. So f composed of g of x gives us 2x squared plus 3. Okay? When we took our notes, we discussed that f composed of g and g composed of f are not the same thing all the time. Okay? There is a special case when they are, and we'll get to that a little later on. All right, so now this time we're taking f of x and we're plugging it into g on the right side, not on your created t-chart other than whatever you do on your notes. So f of x is 2x plus 1. Agreed? Where the x is in g of x, we're now substituting it in with 2x plus 1. Wherever the x is in g of x, we're now substituting it in with 2x plus 1. So now we have 2x plus 1 squared plus 1. Yes? This one? It's coming from the underlying, like the whole f of x is going into g. Are we with me?
Yes.
Okay. So now we're going to simplify. What does it mean when I have a power of 2? You got to multiply it by itself. So that means we have 2x plus 1 times 2x plus 1 plus 1. Okay. How do we multiply this? We use multiple distribution, correct? Okay, whether you want to call it FOIL or the box, whatever makes your heart happy. We're going to multiply 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is, and 1 times 1 is 1, and then we still have our 1 to bring down. So now we're down to combining like terms. Does 4x squared have a friend? Nope. 2x has a friend. We have 2x, and that makes. And then 1 has a friend, and that makes. Our final answer is. Okay. Do we see the difference between f composed of g and g composed of f?
Yes.
Okay. This took a little longer than I anticipated. Which two? Which two? There's a lot of two. These two? 1 plus 1. All right. So now you have your exit ticket.